The last thing we're going to do on day 6 is just have a look at these two examples. So we've got our graphs up there which we've been talking about, and it does say if solving for sine x equals a constant or cos x equals a constant, you should always consider the multiple possible values of x, and we're going to look at that in this example too. So use your GDC to find all the values of x, where x is greater than or equal to negative pi and less than or equal to 2 pi. This is important because this is showing us, first of all, that we should be in radians. And it's also telling us which answers we're going to accept for x. So let's take a little look at that now. So sine x, where's my calculator gone? Here we are. Let's get rid of this. We want sine x, and it's equal to a half. Okay, I need to be in radians, which I am not. Let's do that. Okay, looking at my calculator, I can see 2 points where they're intersecting, which is representing solutions to this equation. However, if I had a different window, slightly different window, I'm going to get more solutions. I've now got 1, 2, 3, 4, 5, 6, 7 on my screen at the moment. So I have to be mindful of this domain. I'm only going to go down to negative pi for my solutions, and I'm only going to go up to 2 pi. Looking at this, so negative pi is roughly negative 3.14. I can see I'm much too far down here. I'm still too far at this next intersection, and this one too. Okay. If I think back to my unit circle, I know that all the way down to negative pi, the values of sine, this is the lower half of our circle, the values of sine are going to be smaller than 0, so it's not going to intersect a half. And that is this part of my curve here. So I need to keep going. This is smaller than 2 pi, this is smaller than 2 pi, and this is greater than 2 pi, because 2 pi is the end of this wavelength here. So my two solutions will be these. Now what I should do is draw a little sketch of what I'm looking at to show how I've reached my solution. So I'm going to draw a little sketch. It's a bit of a wonky sketch. Go down there, and I've got a half, which is roughly here, and then these are my 2 points that I'm looking at. So let's go back. Calculator, keep going. Let's find the answer. So I'm going to go to function, intersection, and hit OK. There we go. So my solution is the x value, because I'm solving an equation in terms of x. So let's say that is 0.524. So x equals 0.524, and it also equals, let's get the other one, function intersection, 2.62. 2.62. Okay. It's the same idea for the second example, so I'll let you have a go at that. The answers will be on It's Learning. The final example that's in our packs today is this. This is something called exact solutions, which you might have looked at in grade 10. Obviously, we could use our calculators to find sine 45 very easily. We'd just hit sine 45. I'm going to make sure I'm in degrees because we've got degrees here. And I get this. If I was in CAS mode, perhaps I'd get an exact solution, but we're asked to use the triangle to find an exact solution. So I've got 45 degrees here. We know that sine is the opposite over the hypotenuse, so it's going to be 1 over whatever this is. And we can find this length quite easily using Pythagoras' theorem. So it'll be 1 squared plus 1 squared comes to 2, and this hypotenuse will be the square root of that, so the square root of 2. As I want an exact expression, I'm just going to leave that as root 2. So sine 45 is equal to 1 over root 2. We should always rationalise our denominators. So I'm going to, in case we've forgotten about that, multiply the numerator and denominator by root 2. Okay, so we get root 2 over 2. Sine 45 equals root 2 over 2, and that is the exact solution to that. You can have a go at cos 40, in fact cos 45 is the same, isn't it, because it's still 1 over root 2. And then we can use our results that we looked at earlier to answer these. So that was AI. Let's just chop down I cos 45 is also root 2 over 2. So sine negative 45, we know from before that sine negative 45 is equal to the negative of sine 45. So it must be equal to the negative of this. Okay, then part II, we're asked for cos negative pi by 4. Now, this must relate to what we've been doing because it says hence. So pi by 4, well, pi radians was 180 degrees, so pi by 4 radians will be 45 degrees. So it's the same as this. So it is equal to, the cos of a negative angle is equal to the cos of the positive version. So it stays as root 2 over 2.